Hello and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nook and I'll be helping assist with the demonstration today. The demonstration today has to deal with a basketball and a tennis ball. Now this demonstration is very similar to a viral trend that a lot of you might be seeing where people will take beverage on top of a basketball. They'll release it, and then as the beverage gets hit off by the basketball, they try to catch it in their air and take a drink. Well, we're going to try to understand why does that happen? Why does this bottle, when it gets hit off by the basketball after being dropped, go off in all these different directions? Well, the concept that we're going to be talking about with this today is the conservation of linear momentum. Initially, when we come across this, it's just talked about the conservation of momentum. It's because we were usually talking about translational dynamics and translational motion. Later on, we'll also be talking about the conservation of angular momentum, which has to deal with objects rotating. So, with the conservation of linear momentum, we have that before any collision and after any collision, that the momentum initial has to equal the momentum final. Now, some of you might be asking, well, what is the definition of momentum? And the definition of momentum is that it's just equal to the mass of that object times the velocity, not the speed, but the velocity of that object. So this means that momentum is a vector. So that means all the momentum in the x direction before a collision has to equal all the momentum in the x direction after the collision. Same thing in the y. This is where you're going to have to be careful in the future if you're doing any momentum problems, is that you actually have to look at all the directions involved. Whereas energy is a scalar quantity, and we don't have to worry about that as much. So now with this concept, we have to think about, if I took a tennis ball, and I dropped it here, it barely comes up back to my knee. Take this basketball that's dropped at about my chest level, comes back to about my hip. But now, if I was to put this tennis ball on top of this basketball, this tennis ball will actually shoot above my head. And we're kind of thinking, well, how does this happen? Why does this occur? And that's because of a collision. So what we might have with this, if I was to put this tennis ball on top of the basketball and release it, we would say then, it's like, or if in particular, if I was to release it a little bit above it, this basketball would go and accelerate towards the ground, it would hit it. Well, then this basketball would bounce back up with hopefully the same velocity that it was hitting the ground with, called an impulse. Now remember, impulse is defined as big J, and it's just equal to the force over the change in time. Or in this case, it's going to be equal to the change in momentum. So hopefully, if it's a perfect impulse, we'll have the momentum hit the ground, it'll release it and have the basketball bounce off the ground with the same momentum. Not going to actually be true in real life, but it's going to be relatively close. So now this basketball is going to be coming back, and all of a sudden now this ball is going to be coming down, and they're going to collide. Now this tennis ball is going to have some initial velocity pointing in the negative y direction, but this basketball, being more massive, is probably going to be bouncing back with a much greater velocity going in the positive y direction. So that way, when these two balls collide, most of the velocity will go into the tennis ball, which will shoot it up to a high velocity and shoot up to a great height. Compared to the basketball, will change slightly, but not terribly drastic. So this is where instead of maybe it coming back to about my waist, it might come back to my thigh. And that's because the basketball is much more massive and moving with much more velocity than the actual tennis ball is initially. So now we're actually going to try to do a little demonstration where hopefully when this hits the ground, the tennis ball doesn't hit me in the face. If it does, who knows, maybe it'll be on America's Funniest Home Videos, at which point education meets comedy, at which point a lot of us are going to just be laughing our butts off. So, here we go. I'm going to have this a little bit above the basketball. And it hit the ceiling and bounced back. So I'm going to try to hold this ball maybe a little bit lower and see if we can actually do it again. And it hit the ceiling again. So And a lot of why these balls are able to bounce back so quickly is because this is filled with air and it's very elastic material. Same thing with this. This has some air inside of it, possibly. I don't know. I haven't opened up the inside of a tennis ball in a long time. But I do know that there is a hole in here and that this also has some air. So this is very elastic as well. So I'm going to try to do this in a smaller. And at that point, it got to the first row. So this is where, with those kind of challenges that you see on YouTube or other little situations, is to think about the conservation of momentum. And that if you have it on the ball or above the ball, how much is that going to change after the collision occurs? So, thank you for watching this instructional video, and have a wonderful day.